Hi, I believe this scene is very familiar for us as a Malaysian, especially when we are driving on the country road, right? It is oil palm tree plantation. And the oil palm tree is a very important economic plant as it contributes up to 3% of our country GDP and it is involving in our daily life usage as well. And however, the oil palm tree community facing a very serious infectious disease, namely BSR disease, which can cause yield loss up to 50%, and the infected tree can die within 6 to 24 months, and it can be cured during the early stage of the infection, and it is very hard to detect during the early stage of infection. Hence, it drives us to present our research on deep learning approach for BSR disease detection of oil palm tree using RGB image analysis. And the problem of detecting the BSR disease among oil palm tree is the visual characteristic between the healthy and also the BSR disease infected oil palm tree is very similar. And it is very difficult to detecting the oil palm tree within the crowded region, as you can see the placement of the oil palm tree in the plantation region is very crowded. Hence, we aim in this study we aim to propose a deep learning-based computer vision algorithm to effectively and accurately detecting the oil palm tree by using the BSR disease within oil palm tree by using UAV images accurately. In this study, we propose a novel multi-convolutional residual unit, namely MCR unit, to improve the segmentation performance, and also we propose a novel overlap contour separation algorithm as an image post-processing algorithm to improve the detection performance as well. And hence, we propose a BSR disease detection algorithm, which you're implementing the MCR net to segment the input image into the feature maps and propose an image post-processing algorithm to post-processing the segmented feature map to accurately defining the class and on the uh, input image by classifying whether it's a healthy tree or the BSR disease infected oil palm tree. And here's the data set that we are using in this study. And here comes to present the multi-convolutional residual unit or the MCR unit. The main architecture of the MCR unit is basically same with the original unit architecture. However, we improve the MCR blocks as you can see at the right hand side here. We implementing multiple convolutional kernel sizes to improve the diversity of the extracted feature maps and also a residual connection to improve the vanishing gradient problem. And here comes the problem to MCR unit blocks. How do we optimize the combination of convolutional kernel sizes within the MCR blocks? Hence, we implementing 4 different convolutional kernel sizes of 1, 3, 5, and 7, and producing 11 different combination of MCR blocks. And we run a test, and we found out that the MCR blocks of 3, 5, and 7 is gives the best result among them. And here comes to the proposed overlap contour separation algorithm, which we aim to remove the boundary of the overlap contour, as you can see in this image. The general idea of this algorithm is we implementing the distance transform to determine the center of the ground truth contour, and we expand the contour and determine the boundary, and then we remove the boundary. From the training performance, we can see that the MCR unit consistently use the others unit family architectures with a lowest loss and highest IOU and dice coefficient. In terms of independent sample z-test, the MCR statistically shows that the MCR unit consistently use the other unit family architectures, as you can see in 4 different evaluation metrics. The p-value of other unit family cannot is not exceed 0.05 threshold as well. And we run a test on PR curve analysis and OC curve analysis. The MCR unit shows the highest area under the curve and also the break-even value as well. And in terms of the qualitative evaluation, goes to the MCR unit. Use the lowest overlap region and also uh, the lowest unsegmented region as compared to the other unit family architecture. And, and here we run an ablation study on OVCS algorithm. We found that applying OVCS algorithm is very effectively in removing the overlap boundary, hence improving the detection performance. In the and we show that our proposed method actually use a better result as compared to the object detection method, traditional object detection method as faster as CNN in terms of precision, recall, and F1 score. In another interesting finding in this study can found that we not only can detecting the health status of the country, we also can show the infected region in order to increasing the reliability of this algorithm to the country community. As you can see, the infected region is segmented in the red region and the healthy region is segmented in the green region. In conclusion, we propose a very effective BSR disease detection algorithm uh, which based on the deep learning based segmentation algorithm along with an image post-processing algorithm, and it shows a very strong potential for large scale oil palm tree hill monitor. And this study we also fulfill the SDG of 2 zero hunger 12 and also the 13 in order to fulfill the SDG. And we highly recommend the readers to read our publication, especially on computers and electronics and agriculture, to understand more detail of our work. And here comes to the GUI demonstration. First, we load an image, then we inference with our proposed algorithm, and it takes around 8 seconds to processing a single image, and we can see that it is very effective in detecting the unhealthy tree in the red bounding box and healthy tree in the green bounding box. And thank you for your for listening to my presentation. If you have any question, please contact my email as well.